All right, we're going to look at a Zilotek 9 watt, 130 milliamp, 750 lumens bulb, and tear it apart and look at how it's made, and do a diagram. Okay, so this, you have to turn it a little bit. It's got, as you can see, 4 tabs on each side. Housing's got at least 2 that are locking. So this comes off pretty easily. It doesn't have glue like the other ones do that you see all over the place. And it has a 15 LEDs and a voltage regulator, or a current regulator. And I already have one completely ripped apart. So you can look at that. So the housing, it's got aluminum, either molded or pressed, and then the plastic is molded around it in the shape it is. Standard socket, button, the LED plate, just positive negative wires coming off it, and the small circuit card that goes inside with a fusible resistor, a couple capacitors, bridge rectifier, and a couple resistors. So let's take a look at what this looks like. And move off to the side a little bit. Okay. That said, it's a 9 watt, but it's running a little higher, like 9.6. And a power factor of 0.62. And it does have 130 milliamps, like it's stated. Okay. Move that over. Let's see here. Kind of blinding. Let's take a look at. Okay. That's pretty bright. Oof. Actually, I can't see. It's way too bright. How about that? There we go. Okay. So, between positive and negative is 152, 153 volts DC. And then, let's see here, I think pin 1. So between positive and pin 1 is 137 volts DC. And let's see, looking at that. Looking at these individually, it looks like there's 2 elements inside each of the COBs. Let's go back and try an individual. 9. I think that was like 9.1 drop over each COB, which is like I said, it only looks like there's 2 in there, but maybe there's a series of 3 and 2 in parallel. I'm not sure. Alright, then let's look at how this thing was assembled. So when I took this apart, this has a couple tabs in the back. So this is actually inserted from this side. And this, what you'd consider the ground, has to go inside there and is for some reason touching the inner core. So building this seems kind of odd because you're having to insert it from this end, and then you'd also have to then afterwards solder these two wires on. So it's not like you can build it and just slide it in like I've seen in other ones. And you're also having to, if you can even see the, feed that through there, bend it over, put the tab in. But just having two wires come out here where you'd have to either have this pressed in place and hold them and solder them seems kind of like a lot more time wasted building something like that. Okay, so when I do the diagram, I'll show that. Okay. Okay, so there's the diagram. And, alright, so let's bring this over into focus. So we have a fusible resistor, 4.7 ohms. And then you have two small resistors connecting to your capacitor, the 0.33 microfarad. There. Going into the bridge rectifier, which is an MB6S. Out of that we get the other resistor, which is a 330K on the back side there. And an electrolytic capacitor, which is 200 volt, 10 microfarad. And then that's where we go into the yellow and white wires that come up into the heatsink. So from there we go from the positive wire to the positive wire to one side of the LED chain, go all the way around and back, and then that connects to pin 1. The ground is actually connected here, or what you'd call the ground, the yellow. And pin 3 then goes through these two resistors in parallel. And those are for setting the current limit. So this chip is a POWTECH PT4515, and that is a single stage linear LED driver, as it says it is in the data sheet. It says it has over 10 protection on it, and there's a calculation on the data sheet for how much current is going through it for the LEDs, and it says it's 500 millivolts divided by what you set the external resistance as. That comes out to be 66.6 milliamps, but in the same documentation it says that the peak is 60 milliamps. And when I tested this in between, it was actually showing 61 milliamps. So I'm thinking this is driving high, and that's why I probably have a couple burnt out ones, because it's going max through this, and I don't think any of the LEDs went bad or any of the other components. It's more than likely the driver. Okay, and then if you have any questions or comments, leave them in the comments below. Thanks.